Hi, everybody, and welcome to week 4 topics. I'm going to go over the first few that are not from the graphing problems. Question 1. Deandra needs to memorize words on a vocabulary list for Spanish class. Deandra has memorized 16 of the words, which is 1/4 of the list. How many words are on the list? If 16 is equal to 1/4 of the whole list, I could write it like that. Now I just need to solve this. I could multiply both sides by 4, which cancels with my 1/4, and I get L equals 64. There are 64 items on the list. Question number 2. I have these two functions that I'm going to graph on a number line, and I want to figure out what this means. And always means intersection. Intersection has a symbol that looks like this, and it is what they have in common. That's what the intersection is. Or is union. When we get to that, we'll talk about it. I am now going to make a number line. That's the first thing I want to do, always make a number line. So here's my 0, 0, 1, 2. I only need to go to 2 because it's less than or equal to 2. And I'm going to go here to -1. And then I'm going to graph each one of them separately. I'm going to start with x is greater than -1. I start here, greater than -1, goes that way. Then I want to graph x is less than or equal to 2. I start here, and I go this way. This is less than or equal. And since they're both greater than or equal or less than or equal, they both get closed circles at their endpoints. Now I want to look and see what they have in common. What I'm going to do is I'm going to move this along the line. And when I touch both lines, that means that they have something in common. Oh, it looks like right there is where it starts. And that's actually at -1. But we know that's at -1 because we know that line starts at -1. And it includes -1 because both points are closed. That means both lines have that point of -1. So in interval notation, I have closed bracket. I start at -1. And where do I go to? Let's grab our line. And I'm looking down at the red and green. And if I move it across, I can see that this is the end of what they have in common at 2. Because then we only have one line after that. And it includes 2 because both points exist at 2. Both points here exist at -1. My answer here would be from -1 to 2. That's what the intersection is. That's what they have in common. So I go from -1 to +2, including both of those, and I'm going to put a line between. Question 3. We have these sets, F and G, and I want to find the intersection. Remember the intersection, what they have in common. Think about an intersection in a road. It's where the two streets meet. It's what they have in common. They have nothing in common. What do I do? We have a symbol. I don't know what symbol we're going to get here, but we have a symbol that looks like this, which means empty set. I can also write the curly braces with nothing inside. That's also the empty set. And that's it. I can't do anything else because nothing's going to go in there. It's the empty set. Next, I want to find the union. The union is the combination of both sets, which means I'm going to combine them. When you get married, you have a union. You have two sides. You have the husband's side and you have the wife's side. When you get married or when the couple gets married, all the people in their families become family. We combine both families into one. That's what a union is. If I want to find the union of F and G, it needs to have every single element in F and in G, which means I would have, again, it's a set. I have -6, and it doesn't have to be in any particular order. -4, 4, 8. That's all the values that are in F. 1, 5, 7. That's the values that are in G. Ah, but look, we missed something. It says here, write your answers. Oh, hold on. Write your answers using set notation in roster form, which is what I did. That is set notation. When I have those curly braces, I have a set with numbers in ascending order and no spaces. Oh, I didn't do that, did I? I have to put these in ascending order. Well, -6, -4, 4, 8, that's good. But 1 has to go here. Ascending order means the numbers are getting bigger. So that takes care of my 1. My 5 would go here. And my 7 would go next to it. And that should be it. 4, 5, 7, 8. That's perfect. Now we have unions and intersections. If you notice, they have the symbols that I showed you. This is union. I just remember it like the U is union and the upside down U is intersection. Now we don't have just values. We have intervals. Whenever we have intervals, first thing I have to do is I have to draw a number line. Don't try to do this without a number line. There's no point because it makes it so much easier. There's 0. I have to go out to +8 and -8. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. Now we're going to put in our lines. if I were to actually just read what this says that set B is equal to the set of all B, which means anything in B, such that that straight up and down line between the two z's is such that z is less than -8. Okay, well, if z is less than -8, I'm going to be starting here at -8, and I'm going this way. And since it's less than, I have an open circle. Now I have the same thing, only z is greater than or equal. I have a closed circle here for 8. And then I have a line. And since it's greater than, it's going to go to the right. That is the graph of these two sets on one number line. If I want to know what the intersection is, I'm going to do the intersection first. It's what they have in common. And those two lines never have anything in common. They're completely separate, which means this is just going to be the null set. Oh, wait, if the set is empty, write DNE, or does not exist. We always want to read all these things. That one's DNE. B union C, well, I want everything, which means I have two intervals. I have an interval that starts at -infinity. I don't have the infinity sign. Here, I'll just do a preview. This is what it would look like, because I want to go from -infinity, which is right here, to -8, which is open. Then I also have from 8, including 8, notice the square bracket, to infinity. That's these things. I connect them. This is another way of saying plus, that union sign, because I'm adding both of those intervals together to make my final solution. Number 5, first thing we need is a number line. And the absolute value of t means something. The absolute value means the distance from 0 on a number line. Here's 0, and I say the absolute value of t equals 4, which means that I have two ways that the distance is 4. The first way is obvious, at 4. But when we talk about distance, we always talk about it as a positive number. Like, I don't say I'm going to my friend's house, they live 4 miles away, and then when I'm at my friend's house, I say I'm going home, I'm going -4 miles. That means distance is always positive. I will say I'm going 4 miles. The distance between -4 and 0 is also 4. That's why we have more than one solution. My solutions are t equals -4 and 4. -4, 4. That's what absolute value means. Here again, I have an absolute value. When I put those absolute values around it, the a doesn't have to be positive, but the number after it comes out of the absolute value has got to be positive. If I start with -25 is equal to -20 times the absolute value of a, I want to get the absolute value of a by itself. To do that, I can divide both sides by -20. The negatives cancel. I get 25 divided by 20. I can simplify that. I can divide 25 by 5 is 5. 20 divided by 5 is 4. And that equals the absolute value of A, which means that A equals 5/4 and also -5/4. Because if I put a -5/4 in for A and then I take the absolute value, it's going to become positive 5/4. 5/4, -5/4. Now here I'm starting out with it being an absolute value. All absolute values equations, which is what we have here, can have 0 solutions, 1 solution, or 2 solutions. When do they have 0 solutions? If I said the absolute value of t is equal to -5, this has no solution, because no matter what I put in for t, when I take the absolute value, it becomes positive, and a positive number can't equal a negative number. No solutions or 0 solutions. I can have 1 solution. The only way I can have 1 solution is if my equation equals 0. Because when I equal 0, I don't have a plus or minus 0, I just have a 0. That gives me 1 solution. And all others have 2 solutions, because I have the positive and the negative solution. If I have the absolute value of t is equal to 5, I have 2 solutions, 5 and -5. Now that we know that, we probably only have 1 solution here because I don't have a positive and a negative 0, which means all I really have to do for this problem is say 3a plus 10 equals 0. That's it. Now I solve for a. I subtract 10 from both sides. I get 3a, this cancels, equals -10, because I'm subtracting 10 from both sides. I divide both sides by 3, which gives me a is equal to -10/3. If we put that in for a, we'll get 3 times, here I'll write it down, 3 times -10/3 plus 10. I cancel the 3's. I get -10 plus 10, which equals 0. Check. I don't have a positive and negative of the a. The a is inside the absolute value. If I put a positive 10/3 in there, I won't get 0. I have 1 solution here because it equals 0. -10/3. -10/3. Check. Again, I start with 6 equals -3 times the absolute value of x minus 5. I can't do anything until I get that absolute value by itself. I divide both sides by 3. I get -2 equals, this cancels, absolute value of x minus 5. Well, can the absolute value of x minus 5 equal -2? No way. This is going to always be positive. It can never equal a negative number. So this would have no solution. All right, we have 9. I start with -45 equals -2 times the absolute value of 2w plus 6 plus 19. Some of you might have a tendency to say 45 is negative, so it's got to be no solution. But you can't always say that. You have to first solve for the absolute value. First thing I'm going to do is I'm going to subtract 19 from both sides. And I get negative 64 equals negative 2 times the absolute value of 2w plus 6. And this becomes 0. I divide both sides by negative 2. This cancels. Now that negative 64 over negative 2 becomes positive 32 equals the absolute value of 2w plus 6. Now, I know that what's inside that absolute value, this right here, can be positive or negative. If 2w plus 6 equals 32, take the absolute value, it's 32. If 2w plus 6 equals negative 32 and I take the absolute value, it also equals 32. So what I really need to do is set up two different equations. I set up an equation that says 2w plus 6 is equal to positive 32, or the negative of 2w plus 6 is equal to 32. Because if I put an absolute value around 2w plus 6 or negative 2w plus 6, they're both positive. And now I just solve. I'm going to have two solutions. I subtract 6 from both sides. I get 2w equals 26. W equals 13. I divided both sides by 2. Or, well, I'm going to take that negative, multiply both sides by a negative, and when I do that, I get 2w plus 6 equals negative 32. Again, I subtract 6 from both sides. I get 2w, this cancels, equals negative 38. I divide both sides by 2. W equals negative 19. I have two solutions, 13 and negative 19. You can always put them back in and check. All right, so this is our last problem, and it looks a little different than some of the others that we've had. We start with absolute value of 5a minus 4 is equal to negative 5a minus 8 absolute value. Now, the way we did it before, we would take whatever's in the absolute value and make it either positive or negative. We're going to do the same thing. If the left-hand side is positive, then the right-hand side will be positive. Also, we can make the left-hand side negative and leave the right-hand side positive. We can make the left-hand side positive and make the right-hand side negative, or we can make them both negative. Do we really need to do all four of these? We don't need to do all four because plus equals plus is the same as minus equals minus. And let me show you why. If I start with 5a minus 4 equals negative 5a minus 8, which is where I'm starting with just taking the absolute values off and making them both, and assuming they're both positive, I get that. If I make the left-hand side negative, it's the same as doing this. If I make the right-hand side negative, it's the same as doing this. And these are equal. How can I tell? Let's multiply both sides by negative 1. Well, when I do that, this negative and this negative cancel, and this negative and this negative cancel. And I end up exactly the same place as I started. 5a minus 4 equals negative 5a minus 8. Since that's true, I don't need to do this one because they're exactly the same. So I eliminated one of the equations there. We're going to keep this one. Let's check out the other two. I think they're the same. If I want to make the left-hand side negative first, and I'm going to keep the right-hand side the way it is, or I can say, let's keep the right-hand side the way it is and make the left-hand side negative. Are these equal? Well, yes, they are, because I can do exactly the same thing I just did before. I can multiply both sides by -1. To do that, I have to put parentheses here, multiply this by -1, and multiply this by -1. On the left-hand side, this becomes negative 5a minus 4. On the right-hand side, this negative cancels with this negative, and I get minus 5a minus 8. Notice these are the same. Since they're the same, I don't need both. I can just erase one of them, which means all I really need. So I'm going to take this off. All I really have to do is do a plus and a plus. 5a minus 4 is equal to minus 5a minus 8. That's the plus and the plus. I'm assuming they're both positive. And now I'm going to solve. I can add 5a to both sides, which gives me 10a minus 4 is equal to, that cancels, -8. Then I can add 4 to both sides. Cancel this, and I get 10a is equal to -4. Divide both sides by 10, which gives me a equals -4/10. This is canceling. If I simplify, that equals -2/5. That is one solution. And let's put it into the answer, and then we'll erase it. Now we're going to solve for one side being negative and the other side staying positive. We're going to make the left-hand side negative, and the right-hand side is going to stay as if what's inside is positive. I can distribute. I can add 5 to both sides. This cancels, I end up with 4. This cancels, I end up with -8. 4 never equals -8. There's no other solution. Therefore, I actually only have one solution. Thanks for watching. Have a good one. Bye.